Read the question carefully, but this is just to set up this differential equation, and it says solve the differential equation. Okay, let y be the temperature of the cup of coffee in degrees Celsius and t be the time in minutes, with t equals 0 corresponding to the time when the temperature was 93. So that's the 93 cup of coffee. Okay, so at the beginning means the temperature y when time is 0, that's the 93 degrees Celsius. Okay, this is initial value. Now we have an initial value problem, differential equation, initial value. We need to solve for y. Okay, it's a 93 cup of coffee and it's cooling because it is sitting in a room of 17 degrees Celsius temperature. So this differential equation to solve, we need to separate the variables. dy, y is the dependent variable, so dt can be moved to the other side. So this one is then dy equals negative 1 over 50 y minus 17. I'm just moving dt to the other side. Okay, y minus 17 is a factor and here is a dy, so we need to bring this to left side. That means divide both sides by y minus 17. Okay, this is a whole thing because of parentheses. So divide by y minus 17, so this is 1 over y minus 17 dy equals negative 1 over 50 dt. Now integrate both sides. Okay, when we did this, we separated the variables. Next thing we want to integrate. This is constant dt, means entire derivative is just that constant t. Okay, constant we can pull outside, so entire derivative of 1 dt is just t, and plus c. Here though it's like 1 over y minus 17, its derivative is 1. So this is simply like if we have some function on the bottom and its derivative on the top, that is simply natural log of the bottom. Or you can think like u, its derivative is 1 with respect to du on the top, that's natural log of u. So y minus 17, whose derivative is 1. So this one is simply natural log of absolute y minus 17. Okay, but if we look at carefully, so y is the temperature of the cup of the coffee. Okay, that was initially 93 and it's cooling down to, it is sitting in the room, so it's cooling down. So it might get to 17 degrees if we let it there for forever. That means this temperature is always bigger than 17. Okay, started with 93, so this y is always bigger than 17. So that means this thing is always positive, so we don't need absolute value. We can simply write parentheses here. Okay, that's what I'm gonna do. That way we don't have to worry about removing later, because y is bigger than 17. Y is the temperature of the coffee. Okay, let's find the value of c using the initial condition, which is y at 0 equals 93. Using y at 0 equals 93. Y is 93 when time is 0. So natural log of 93 minus 17. Okay, that's going to be 76. Negative 1 over 50 times t is 0. So this is 0. Nothing, plus c. So the c. Okay, by the way, c is natural log of 76. So let's plug that in here. So this is now natural log of y minus 17 equals negative 1 over 50t plus c is natural log of 76. We are supposed to isolate y, so this is y minus 17. Okay. So natural log, so exponentiate both sides. So e raised to left hand side, e raised to whole right hand side. e and natural logs and x and cancel. So y minus 17 equals, here we got two terms, okay? E raised to something plus e raised to natural log of 76. So it's like e raised to a plus b, that factor says e raised to a times e raised to b. Okay, no plus in the middle. So this one is e raised to negative 1 over 50t times e raised to natural log of 76. E and natural log cancel, so it's 76. So e raised to this means just 76. We are trying to solve for y. So done. I mean, this is 76 times this one is a negative 17. Add 17 both sides. So y equals, so add 17, let me write 17 first, plus this thing, which is 76 e raised to negative 1 over 50t. Okay, you cannot add these two numbers. This is 17 plus 76 times something t. Okay, this is the final answer. In fact, this gives us the temperature of the coffee at any time t.